Right, we were discussing about the dynamics of rigid body, and we had solved a numerical based on that. Let us try to solve few more numerical and try to understand how the dynamics and the equation, dynamic equilibrium equation, can be applied in order to solve few simple numerical, right? So let us take up one numerical wherein this situation is there. There are two rigid bodies which are attached with the help of this frictionless pulley on inclined surfaces with the help of rope. Okay, like this. These are two rigid bodies. They are held in position. Now, this is 100 Newton load. This is 50 Newton load. Let me call this as block A and block B. This inclination is 60 degree. This is 30 degree. Okay. The coefficient of friction uh, between the planes, inclined planes and the blocks, it is given as 1 by 3. Okay. You are supposed to identify the acceleration and tension in the string. Mu s is given as 1 by 3. This is what is given. Okay. And you are supposed to identify the acceleration and the tension in the string. So one thing is very clear, since this is frictionless, ideal, because of which uh, tension value throughout this string, it will be common, it will be same. Yes, isn't it? So this we have identified in the initial stage itself that this because the pulley is frictionless, the tension will be constant throughout. Okay. Now what is the second part? Second part is that, see over here, the motion is not known actually, and we cannot assume the direction of the motion of the block. Reason I will let you know, because here the coefficient of friction is given, right? The frictional resistance that can be offered with respect to the surface, that value is although it is not directly given, but it is given in this form of µs, coefficient of friction. So based on this, we can identify the actual motion of this block A and B. Okay, so let us try to identify in which direction each block will move, whether the block B moves upward or this moves upward. That's what we need to identify. Okay, so in order to identify the motion of these blocks, first step is to neglect friction. Neglect friction. Fine. And let's say neglect friction for block A. And if I neglect the friction, then I will draw the free body diagram associated to block A. Okay. How many components do we have? So let me consider these to be the axis for block A. Let this be X, this be Y. Okay. So what exactly we have? We have this tension force. If I draw the free body diagram, this will be the tension force. This will be the normal reaction for block A. Then there is the self weight. What is the magnitude? 100 Newton. Okay? And this angle will be 60 degree from the geometry, isn't it? This angle will be 60 degree. Am I right? So with respect to this, what I can say, these are the components. And what I am doing, I am not using any type of frictional resistance over here. So because of that, this is the free body diagram, isn't it? Is this fine? So this component shall be 100 sine 60, and this will be 100 cos 60. Am I right? This component horizontal will be sine component, because if I extend this line of action of force, this will be 60 degrees, so this will be 100 cos 60. Okay. So now with respect to this frictionless free body diagram, you can say, what I can identify from here, I can say that if I apply summation of forces in x direction equal to 0, okay, because this is in equilibrium, right? Therefore, T will be equal to 100 sin 60. बराबर है? Is this okay? So what will be this value? How much will be the value? 86.67. Correct? Yes, 86.6. Okay, okay, 60. 86.6. Now, this is the T value. Now let us try to identify whether the net force which is acting on this complete, you know, block, whether it is sufficient enough to say, okay, so this is the T value which we have identified by assuming this to be the by neglecting the friction for block A. Okay, that is what I am saying, that since block A is at rest, since it is at rest, I was in position to apply this equation of equilibrium, and based on that I have found out the value of the T. Okay. Now what I will do with respect to this T value, I will now go to block B, right? So again, for block B, see the condition is same. I have neglected the friction. So for block B, this will be the free body diagram. Again, I am assuming this to be the axis. Okay. So this is y-axis, this is x-axis, right? This will be the tension force. Okay. What is the weight of block B? It is 50 Newton. This is 30 degree. So this will form, this will be 50 sine 30. Am I right? And this will be 50 cos component, 50 cos 30. This will be the normal reaction and the B. True. Now for this, again it is at rest. This being on rest, let me say that by the virtue of this tension force, what will be the net amount of force which will be acting on this block B? Okay, so what I will write, therefore, net force acting on B without friction. This is without friction. So we have drawn the free body diagram associated to the case that it is having no frictional resistance for time being. Right. So what will be the net force which will be acting? Now you can understand the force which is acting on this complete block. It is in two directions. First is the vertical and another one is the horizontal. However, the horizontal force will be responsible for the motion of this block, right? So we will be interested in calculating the net horizontal force which will try to cause the motion of this block. So what will be the amount of net force? So how much it will be? Now see, here we will assume the sign conventions. The sign convention in the x direction which is pointing upward, that I will be assuming positive. Similarly, this will be positive and this will be negative. Upward directing y axis, I will assume this to be positive, this to be positive, and opposite to it will be negative. Okay, so have you understood this sign convention? Okay, positive value, I am assuming it to be in the upward direction, that I will be keeping consistent. Is this okay? Now with these sign conventions, now can you please let me know what will be the net force which will be responsible for causing the motion of this block acting on block B? कितना रहेगा वो? So I will write down the equation T minus 50 sin 30, or this is 86.6 minus 50 sin 30. How much is the value? Can you please let me know? 61.6. This came out to be positive value, isn't it? This value comes out to be positive value. What is your interpretation? What does that mean? That means this net force, whatever net force we have calculated on block B, with the help of this understanding that block A is at equilibrium, or it is at rest, this net force which is acting shall be in the upward direction. Okay, that means this block is going to move in the upward direction. And even if I consider frictional resistance, okay, now if I consider the frictional resistance for time being, now even if I assume, even if friction is assumed for case B, for B, for block B, okay, what will be the frictional resistance value? FB for time being, mu S into NB, correct? What is the NB value? Summation of force in y direction equal to 0. NB will be equal to 50 cos 30, correct? And therefore, friction for block B, it will be 1/3 50 cos 30. So, how much is this value? How much does this come out to be? 14.43 Newton. So just try to imagine, even if the frictional resistance is provided over here, this frictional resistance is not sufficient enough to keep this block B in position, and with the virtue of this force which is acting in the upward direction, this will move the block in the upward direction, and this frictional resistance, whose magnitude is just 14.43, will not be sufficient enough to keep this in position, or it will not allow this to stop moving in the upward direction, right? So this is how the direction of motion can be identified. Now similarly over here, if we try to identify the motion of the block A, for that what we will do? We will keep this in position, or we will keep this at rest, and then we will identify the net force, which first of all we will identify the T value, and then the net force which is acting on this block A. So you will find over there this block will move in the downward direction. That is, the net force which will be acting, it will be in this direction. Okay? So have you understood? So this is how you are supposed to identify the motion of the blocks if the frictional resistance is given to you. If the frictional resistance is not given, you are free to assume the direction of the motion of the block, and based on that you can find out the values, right? So this is what we have identified, and based on this, now the next step shall be, so I will rub this part. Now we know that this block A moves in the downward direction and block B moves in the upward direction. This movement is known to us. Second step is assume friction and calculate the acceleration response. For that you draw the free body diagram for both the blocks. Block A and block B as well. Other sign conventions shall remain same. We will assume this thing only. This is positive, again this is positive. T, T. Now these T values will vary. Okay. So I have drawn the components directly instead of the self weight. Okay. This is now the NA. This is NB. Correct. Next is incorporation of the frictional resistance. So see, since this is moving in this direction, so let me call this as movement of displacement of block A. Let me call it as S suffix A. Let me call this as S suffix B. Okay. So since this is moving in the downward direction, the resistance offered shall be upwards. Fa mu s times Na. Okay, and this is F. Since this is in the upward direction, the resistance offered shall be downward. This is FB. FB we have already found out, 14.43. Okay. Can you please identify the Na value? See, this was 100. How much it is? This is 60 degrees. So this is cos 60, and this is 100 sin 60. So can you please tell me the value for Fa? To find out Fa value, you just have to calculate summation of force in y direction equal to 0. Na comes out to be 100 cos 60. and therefore FA will be 1/3 of this value. How much? Are you getting it to be 16.67? Just check. Yes? Yes? Is this fine?
Yeah, yeah.
Now the next step is uh, to identify the inertia force which will be acting based on the displacement. Since this is moving in the downward direction, naturally the inertia force shall be acting upwards. So what is this? Inertia force, mass into acceleration, right? So we convert it into weight, so W by G or 100 by G into acceleration of block A. This is moving in the upward direction, therefore inertia force W by G. So this is 50 by G into A suffix B. So this completes the free body diagram. And now we are free to make use of the dynamic equations of equilibrium. Okay. So what are the dynamic equations of equilibrium? Summation of forces in x and y direction equal to 0. That is what we will be using. Before that, uh, we need to identify the relationship between, you know, AAAB. For that, what we can say before this step? Kinematic relation. Kinematic relation. So kinematic relation is nothing but the total work done, that is internal work done, that should be equated to 0. Okay. So what is the internal work done in this case? Now just try to understand, this block A is moving in the downward direction, and this is the internal force which is getting developed in the form of tension in the string. T into SA will be the work done. But over here, since displacement and force, they are acting in opposite direction, therefore the work done will be negative. So minus SA into T. And since it is total internal work done, I will have to consider the work done of the associated block B also. Okay. So what it shall be? Now here, both the displacement and force, they are in same direction. So T into SB equal to 0, and therefore what I can say, SA equal to SB, or in other terms VA equal to VB, or AA equal to AB. That's it. So we have found out the equation, the relationship between AA and AB for this case. Now fourth step is apply dynamic equations of equilibrium for, let's say, block A. T minus 100 sine 60, then plus 16.67, that is this FA value, plus 100 by G into AA. Anything else? Equated to 0. Similarly for block B. Now, so this is positive. Here positive, where this is positive. We are assuming that whatever is in the upward direction, that is positive. So this is positive, then minus 50 sine 30, then minus 50 by g into AB, and this is again minus 14.43 equal to 0. Is this okay? Then you solve these two equations by substituting AA equal to AB. Okay? Based on that, you calculate AA and then T. ठीक है? Is this fine? Is this okay, students? I will take up next numerical. You can please find out the answer and let me know in the next class. Okay? Okay, now a bit change. There is small pulley over here, and over this small pulley, again one more pulley system can be found, and it is over here like this. Okay? And over here at the center, one block is attached. Okay? The slope is given. Okay? This is block A, block B. 300 Newton, 200. Coefficient of kinetic friction is 0.2. ऐसा दिया हुआ है. Okay, you are supposed to identify the acceleration of block B and the tension in the cord supporting block A. Okay, you are supposed to find out acceleration of block B and the tension in this cord which is supporting block A. So very quickly let me know. Dekho, everything is, the pulley system is frictionless. So can you please let me know what amount of uh, tension force do you expect over here? यहाँ पे कितना टेंशन फोर्स रहेगा? How much? कितना रहेगा ये?
200 Newton.
Okay, 200 Newton, or let's say for time being T. Since this is T, यहाँ पे कितना रहेगा? Okay. Now see, this rope is getting wounded over this pulley. So naturally, what magnitude of tension do you expect over here? T. Great. What about here?
12.
Yes,
12.
300. No. Now just see. I will draw the free body diagram now. देखो यहाँ का free body diagram आपने निकाल लिया. This is okay. T. Then what you have said, because this is frictionless, the magnitude of tension will be constant over here. Then again, since this is the rope which is getting mounted over this pulley, again the T value will be same, right? I need to find out this tension value over here. Let me say that this is P for time being, and I will consider the free body diagram of this stuff only. I will redraw. This will be like this. Okay, this will be like this. So this magnitude is T, this is T, and this is T. Okay. From here, what do you think should be the value of P? Yes, you can consider this. Yes, this is X and this is Y, let's say. So summation of forces in X direction, since it is an equilibrium equal to 0. So P will be equal to 2 times T, correct? Therefore, you will see that for this case, this is 2 times T. Take. Now, what generally what we consider is, since this 200 Newton is less than 300 Newton, the case may be this 300 Newton block may move in the downward direction. That's what we need to check. Okay. Here, the tension force is 2 times T. What will be the effect if this tension force is 2 times T? That's what we need to identify. So again, what we can do is we can neglect the friction. That means what we are doing, we are determining the motion of these blocks, in which direction this will, move. So what I can do is I can assume this block A to be at rest. So assume block A at rest. Okay? That is, it is in equilibrium. And by assuming that, I will draw the free body diagram, and I will neglect friction. So since it has no surface attached to it, this will be free. 200 Newton, this is tension force. Therefore, summation of force in y direction equal to 0. T comes out to be 200, as you people have already told me. Okay. Now let us see that whether with the help of this T value, what will be the effect on this second block B, right? So we are neglecting friction. Okay, we have assumed this block to be at rest. We are neglecting friction, and with that help, we will be drawing the next free body diagram for block B. There is no friction right now. Okay, and I will draw the free body diagram for the pulley system as well, just for your understanding purpose. वैसे तो I have told you. Okay, it will be like this, right? Then this is what is the angle value? Can you please let me know what will be the angle value? tan inverse of 3/4 ये कितना आता है 36.8 बराबर है this angle and therefore you will see that these will be the components. This will be what is the value? It is 300 sine 36.8 and this will be 300 cos 36.8. Am I right? ठीक है? Fine. Now the net force acting on block B in order to move this block, and you know that this block will be moving in the horizontal direction or on in the line of the inclination. It won't move in the vertical direction. Okay? So net force acting on B in this direction, I will assume this to be positive, and this side to be negative. So can you please let me know what will be the net of force acting? It is 2 times T minus 300 sine 36.8 or 2 into 200 minus 300 sine 36.8. So how much is this value? Please calculate.
220.2.
Okay, 220 Newton. How this came out to be positive? So since this is positive, that means this block will move in the positive direction or upward direction. Although 300 is greater than 200, but because of this arrangement, what do we get? Tension over here, it is 2 times T, and because of this 2 times T, this will compel this block B, although it is heavier, to move in the upward direction, and this block A will be moving in the downward direction. Okay? So therefore, now let us verify whether our statement is correct if we consider the frictional resistance. So if friction is considered, what will happen? Friction for B is equal to mu K times NB. Okay. So summation of force in y direction equal to 0. That will be NB is equal to 300 cos 36.8. And can you please let me know what will be the value of FB? Mu K is given as 0.2. NB is it 240? So it will be 48 Newton. And this 48 Newton is not sufficient to avoid the movement of this block B in the upward direction. Right? It will be insufficient and it won't keep this block in position. This frictional resistance won't be sufficient enough to help or to hold this block B in position, and this is going to move in the upward direction. Right? So now we have understood the motion of these blocks. Next step is to draw the free body diagram associated to friction or by assuming friction. Next step is consider friction and draw free body diagram. Okay, I will draw the free body diagram. Next, you can solve it by your own. This will be 2T This will be NB. We know that this is going to move in the upward direction. So frictional resistance shall be downward. That's for B. Okay. Next is this thing. These components you can drop. And since it is moving in the upward direction, the inertia force will be in the opposite direction. So this is 300 by G into AB, right? And the next free body diagram will be for the block A. This is T. Okay, this is 200 Newton. This block A moves in the downward direction. Inertia force will be acting in the upward direction. So this is 200 by G into A. You develop relationship between AA and AB by assuming the kinetic relation. Kinetic relation. Over here, what you will find is the relationship is like this. Okay, and therefore 2 times SB is equal to SA, and therefore 2 times AB equal to AA. This is the only change. Rest, you can formulate the dynamic equations of equilibrium and solve it. Okay, is this okay?
Yes.
Fine. So you please solve these numerical examples, and we will discuss the answers in the next class. I will stop here. Thank you.
Thank you, sir.